Sometimes the fossil record doesn't just tell us what lived in the past. In rare cases, it tells us what happened. Most fossils preserve anatomy, bones, teeth, wings, fragments of creatures long gone, but occasionally they capture something far more specific. A moment, a sudden interaction between predator and prey, a split second of violence frozen in stone. This fossil does exactly that. It shows a flying reptile, a pterosaur bearing bite marks so precise that scientists can identify not just the attacker, but how the attack likely unfolded. A crocodile-like predator, a vulnerable moment near water, and physical evidence that survived millions of years. Most fossils are silent about death. They tell us what an animal looked like, how big it was, how it moved. But predation is rarely preserved. Soft tissue disappears, bones are scattered or destroyed, evidence is erased long before burial can protect it. That's why fossils showing clear signs of attack are extraordinarily rare. And when they do appear, scientists approach them cautiously. Damage can come from erosion, from pressure underground, from scavengers long after death. So when paleontologists encounter pattern damage, marks that repeat, align, and match known anatomical structures, they pay attention. Because that kind of damage tells a story. The fossil at the center of this discovery belongs to a pterosaur, a flying reptile that lived alongside dinosaurs. Pterosaurs dominated prehistoric skis for over 150 million years. They varied widely in size, from small, gull-like animals to giants with wingspans rivaling small aircraft. But flight didn't make them invulnerable, especially near water. The fossil preserves wing bones showing a series of deep puncture marks. Not cracks, not random fractures, but indentations with consistent spacing and penetration. Marks that immediately raised suspicion. They were too organized to be accidental, too deep to be environmental damage. These were bite marks. Researchers analyzed the fossil using high-resolution imaging and comparative anatomy. They measured the spacing between punctures, the depth of penetration into bone, the angles at which force was applied. These details matter because different predators leave different signatures. The results aligned closely with the teeth of ancient crocodilian-like reptiles, known from the same region and time period. The spacing matched crocodilian dentition. The depth indicated a powerful bite. The fracture patterns suggested a sideways clamping motion, exactly how crocodilians seize prey today. This wasn't scavenging after death, it wasn't damage caused by burial pressure, it was an attack. Pterosaurs frequently hunted near lakes, rivers, and coastal waters. They skimmed surfaces, snatched fish, landed briefly to feed. That behavior came with risk. Crocodilian predators are ambush hunters. They remain nearly motionless, submerged, invisible until the moment they strike. The fossil evidence suggests the pterosaur was seized either during low flight or immediately after landing. The predator clamped onto the wing, a critical target. With the wing disabled, flight would have been impossible. Escape ended instantly. What followed likely took only seconds, but those seconds were enough to leave permanent marks in bone. Most predation events leave no fossil trace. Bodies are consumed, bones are broken apart, scattered by currents or scavengers. For this fossil to survive, a series of unlikely events had to occur. The remains had to be buried rapidly. Sediment had to cover the bones before scavengers arrived. Environmental conditions had to prevent erosion. Only then could the damage be preserved intact. That makes this fossil exceptional, not just a skeleton, but a recorded interaction between species. This discovery reshapes how scientists understand prehistoric ecosystems. Pterosaurs weren't untouchable aerial predators. They were integrated into complex food webs. Crocodilian reptiles weren't confined to water or land. They exploited moments of vulnerability across boundaries. The fossil shows that danger moved between air, land, and water. Ancient ecosystems were interconnected, highly competitive, and unforgiving. Flight reduced risk, but it did not eliminate it. This fossil doesn't dramatize the past, it documents it. A single failed moment, a predator's strike, a prey animal caught at exactly the wrong place in time. Millions of years later, that moment still speaks. Not as a story imagined by scientists, but as evidence. Etched permanently into stone. If you value documentaries built on physical evidence, not speculation, not exaggeration. Subscribe for more investigations like this. Every story here starts with what the fossils actually show.